Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out practice problems that should closely mirror what you'll see on the Mathematics Knowledge subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB. As always, I recommend that you attempt to work out these problems on your own. That is, after I read a question, you should pause the video, attempt to work out the question on your own scratch paper, and resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the ASVAB. So as you take this practice test, it's in your best interest to not make use of any of those resources. Similarly, I want to mention that in the description of this video, I'm going to include timestamps that are associated with each question. Next to the timestamps is going to be the topic that the question's testing, as well as a link to a video in which I discuss that topic in greater detail. So if at any point during this video you need some additional help, check the description of this video for those additional resources. Finally, I want to say that you shouldn't just take one of these practice tests and assume you're going to see everything that you may see on the ASVAB. Instead, I always recommend that you take at least 10 of these practice tests to fully prepare yourself for the ASVAB. So all those things finally being said, let's go ahead and get started with this practice test. All right, question 1 says, if the area of a triangle is 24 square inches and its base is 6 inches, what is the height of the triangle? So whenever I'm dealing with triangles, circles, and pretty much any other shape on the Mathematics Knowledge subtest, I'm going to draw a diagram more often than not. In this case, we know we're dealing with a triangle. According to the problem, the type of triangle is not specified, so I'm going to draw a simple right triangle. According to the problem, we know this triangle has a base of 6 inches. Again, here's the base, so we know this right here is 6 inches. We don't know what the height is of this triangle, and again, the height would be right here. So I'm going to denote that with an H. That said, we know the area of this triangle is 24 inches squared. So using these three pieces of information, we have to solve this problem. And as it happens, we're going to make use of the formula to find the area of a triangle to plug in what we need to solve for what we don't know. So again, the formula for area of a triangle is area equals 1/2 times base times height. We know what the area is. A is 24 according to the problem. So in place of A, I'm going to put 24. Again, 1/2 doesn't change. That's a constant. We know the base is 6 according to the problem. And we know height is the variable for which we're trying to solve. So we're going to leave that as H. As you can see now, all we have to do is solve for H and we'll be done with this one. Let's start by multiplying 1/2 by 6. 1/2 of 6 is 3. So this becomes 24 equals 3h. Again, we're trying to solve for h, so we want to divide both sides by 3 to get h by itself. This crosses out, leaving you with h over here. 24 divided by 3 is 8. Again, in math, it's customary to write the variable for which you solved on the left. So this is h equals 8. Okay, so the answer to this one is 8. Again, on my website, as well as the community tab of my YouTube channel, I have a 13-page formula sheet that includes all the formulas you need to know for the ASVAB. Of course, the formula to find the area of a triangle is on that formula or reference sheet. So make sure you know this one. You'll probably see it on the ASVAB for sure. All right, number 2 says, in the sequence 4, 12, 36, x, 324, and so on, what is the most likely value of x? So on my YouTube channel, I have 2 or 3 videos devoted to sequences and series. That said, they're probably overkill for a question like this. The key to solving a question like this is to find a value that will get you from one term to the next term in the series or sequence. So in other words, we want to know what's going to get us from 4 to 12. Well, I know 4 times 3 is 12. Okay, so that worked for this first pair of terms. Now we're asking ourselves, what's going to get us from 12 to 36? Okay, and I know 12 times 3 will give me 36. So it appears as if to go from term to term in this sequence, we multiply by 3. So in order to go from 36 to x, we're going to multiply by 3. And in case you can't do that in your head, we're going to do 36 times 3. 6 times 3 is 18, so we're going to bring down an 8 and carry a 1. 3 times 3 is 9, plus 1 is 10. So in all likelihood, the value of x is going to be 108. All right, so that's that one. Number 3 says, which of the following expressions describes the values indicated on the number line above? So as we can see, we have a number line with 2 closed circles followed by arrows. In this case, the closed circle and the arrow is above the values -1, -2, all the way to -infinity. And this one has a closed circle above 1 that goes from 1 to 2 all the way to infinity. In case it's not obvious, a closed circle on a number line means you're dealing with less than or equal to or greater than and equal to. An open circle would mean you're dealing with less than or greater than. So in this case, we're dealing with the 2 I just mentioned. And this line above these values on this number line indicates that these are potential x values. So x can be -2. Since we have a closed circle above -1, x can also be -1. Over here, we see x can be +1, x can be 2, x can be anything greater than 1. Here, anything less than or equal to 1. Okay? Now, the way I'm going to solve this is I'm going to pick some x values, plug them into these equations, and test them to see if they make a true statement. So I'm going to let x be -2, so I can test this side of this number line, and I'm going to let x equal +2, so I can test this side of the number line as well. If I get an untrue statement, I'm going to stop testing the equation, since once I get an untrue statement, it doesn't matter if the other statement is true or not. Okay, so let's go ahead and work on this. We're starting with A, and I'm going to let x equal -2. As we can see, A says x is greater than or equal to 1. In place of x, let's put -2. -2 is greater than or equal to 1. Is -2 greater than or equal to 1? It isn't, so we know this is not a solution to this. This expression doesn't represent what's happening on the number line. All right, let's go ahead and test B now. B says x is less than or equal to 1. Again, let's start by testing x equals -2. So x equals -2. -2 is less than or equal to 1. That is a true statement. -2 is less than or equal to 1. Now let's test the right-hand side of this number line. X equals 2. So in place of, well, we're gonna copy down the equation again. Again, this one's x less than or equal to 1. In place of x, let's put 2. So this is 2 is less than or equal to 1. Is 2 less than or equal to 1? It isn't. This is not a true statement. So although this equation worked when x was -2, it did not work when x was equal to 2. So this one doesn't work either. Let's go ahead and test C now. Again, we're going to let x be -2, and if necessary, we'll test x equal to 2 as well. And we're going to test those in the equation or the expression given by C, notably x is greater than or equal to the absolute value of 1. X is greater than or equal to the absolute value of 1. Let's plug in -2 for x to start. So this is -2 is greater than or equal to absolute value of 1 is 1. Is -2 greater than or equal to +1? It isn't, so that's not a true statement. Since we found an untrue statement, we know that this expression does not represent what's happening on this number line. By process of elimination, we know D is the correct answer. That said, let's plug in our values to see how it looks. So we have, again, we're going to let x be -2 and x be +2. We're going to plug those into this expression. Absolute value of x is greater than or equal to 1. Again, absolute value of x is greater than or equal to 1. Let's plug in -2 for x now. So this is absolute value of -2. It's greater than or equal to 1. Absolute value of -2 is +2. +2 is greater than or equal to 1. That's a true statement, so that works. Now let's plug in 2 for x. So this becomes the absolute value of 2 is greater than or equal to 1. The absolute value of +2 is just 2. 2 is greater than or equal to 1. That's also a true statement. So the two x values that I took from this number line, as indicated by the line above the graph, do work for this expression. So we know D is the correct answer. All right, so let's move on to number 4. It says for all values of x, 3x plus 4 times 4x minus 3 equals. So to solve this one, we're just going to take 3x plus 4 as well as 4x minus 3. And we're going to expand this using the FOIL method. FOIL stands for first, outside, inside, last. So you take the first two terms, the first one in this parentheses and the first one in this parentheses, and you multiply them together. So we're going to do 3x times 4x, which is going to be 12x squared. And then we're going to do outside, which means the outsidemost term in this first set of parentheses, which is 3x, and the outsidemost term in this set of parentheses, which is -3. So now we're going to do 3x times -3, which is going to be -9x. And again, I'm going to write that out for you if you need to see it. FOIL, we did the first set of terms. We did the outside terms. Now we're going to do the set of inside terms. And as we can see, the inside term in this parentheses is 4, and the inside term in this parentheses is 4x. So this is 4 times 4x. 4 times 4x is going to be positive 16x. And then we're going to do the last set of terms in the parentheses. This one's the last, and this one's the last, so we're going to do 4 times -3. 4 times -3 is -12. Let's go ahead and simplify this. We have 12x squared. Now we have 16x and -9x. 16x minus 9x is going to be plus 7x minus 12. So the answer to this one is 12x squared plus 7x minus 12, which we can see is C. All right, let's move on to number 5. Number 5 says, in the triangle above, if the measure of B is 52 degrees, then what is the value of Y? Okay, so first, we have to know that all the angles in a triangle add up to 180 degrees. That's called the triangle sum theorem. So angle A plus angle B plus angle C are going to add up to 180 degrees. Okay? That's going to be useful a little later in this problem. Let's start with what we have. We know the measure of angle B is 52 degrees. And as we can see, the measure of angle B is 2x plus 2. And we know that equals 52 degrees. If we solve this for x, we'll be able to figure out what the measure of angle A is, because we'll know what x is. So let's go ahead and do that. Okay, we want to solve for x, so the first thing I'm going to do, subtract 2 from both sides. This says 2x equals 52 minus 2, which is just 50. Divide both sides by 2. This crosses out, leaving you with x equals 50 divided by 2 is 25. Okay? So again, we know B is 52 degrees. We know x is now 25. So again, a is 4x. We know what x is. X is 25. So this is 4 times 25. 4 times 25 is 100. So we have a being 100 degrees and b being 52 degrees. Okay, so we use some simple algebra to find those values by solving for x. Now we're going to have to use this triangle sum theorem to figure out what y is. So let's go ahead and do that. Again, the triangle sum theorem says all the angles in a triangle add up to 180 degrees. Let me just copy it down here since I'm running out of space. Again, we have the measure of angle A plus the measure of angle B plus the measure of angle C equaling 180 degrees. We know what A is. We found A to be 100 degrees. We know what the measure of angle B is. We were told, according to this problem, it's 52 degrees. We want to find out what the measure of angle C is. And specifically, we know the measure of angle C is going to be y. So this is going to be 100 plus 52 plus y equals 180. Now we're just solving for y, so let's go ahead and work on doing that. 100 plus 52 is 152 plus y, and I'm going to drop the degree symbol right now, equals 180. Subtract 152 from both sides. This crosses out over here, leaving you with just y on this side. And let's do this arithmetic real quick. 0 minus 2 we can't do, so we have to borrow. This becomes 7. This becomes 10. 10 minus 2 is 8. 7 minus 5 is 2. And 1 minus 1 is nothing. So we can see y is the equivalent of 28 degrees, which of course is D. Okay, so pretty challenging problem. You had to combine your knowledge of some basic algebra to solve for x, which enabled you to find the measure of angle A, and then you had to use the triangle sum theorem to figure out what y was. So multiple steps in that problem, but nothing too difficult. All right, number 6 says 25% of what number is equal to x? Okay, so we're going to write a small algebraic expression to represent what's happening here. 25%. Again, that looks like this, but in decimal form, that's 0.25. So this says 25% of what number? Again, in math, when you have an unknown value, you can call that x, and then we have equal to 5. So this says 0.25% of what number x equals 5. Okay? And just like that, we converted this to an algebraic expression that we can now use to solve for x. To get x by itself, let's divide both sides by 0.25. This crosses out, leaving you with x equals, as we can see, 5 divided by 0.25. Now we're doing long division involving a decimal and a whole number. When you have a decimal outside the division bracket, you have to shift the decimal in that number as well as the number inside the division bracket to get rid of the decimal outside the division bracket. So in this case, again, we can put a decimal after 5. In this case, we want to shift the decimal in 0.25 2 times to the right. That's just going to become 25. And we're going to have to shift the decimal to keep proportionality in 5 2 times to the right as well. And we're going to have to fill in zeros accordingly. So this becomes 500. As you can see, we cleared the decimal from outside the division bracket. So now this just says 500 divided by 25. This is actually pretty easy to do mentally. How many times does 25 go into 50? That's 2 times. Therefore, we can just bring up this 0. 25 times 20 will be 500 with no remainder. So x in this case is 20. In other words, 25% of 20 is equal to 5. Okay, so that's that one. All right, number 7 says, which of the following is equivalent to 12 over 25? So again, we have this fraction, notably 12 over 25. and we want to find its decimal equivalent. Again, the key to this problem is understanding that all fractions can be regarded as long division. So you can read this as 12 over 25 as a fraction, but otherwise you can read it as 12 divided by 25. And by working out this long division, we'll convert this fraction to a decimal. Okay, so let's go ahead and get started. We're asking ourselves to start, how many times does 25 go into 1? It doesn't. How many times does 25 go into 12? It doesn't. In light of that, we have to add a decimal here and a 0 here. Again, as soon as we do that, we're going to bring up the decimal right here. And now that we've accounted for the decimal in our answer above the division bracket, we can disregard it right here. So instead of reading this as 12.0, you can read it as 120. And the question becomes, how many times does 125 go into 120? Well, 125 times 4 is 100. 125 times 5 is 125, which is too big. So this has to be 4. Again, 100 times, or 25 times 4 is 100. 120 minus 100 is 20. Now the question is, how many times does 25 go into 20? It doesn't, but that said, we have a free 0 here that we can bring down. And the question is, how many times does 25 go into 200? Well, 25 goes into 104 times, therefore 25 goes into 200 8 times. 25 times 8 is 200, so we can see there's no remainder. In other words, 12 over 25 can be read as 12 divided by 25, and using long division, we can see that that in decimal form is 0.48. All right, let's go ahead and move on to number 8. Number 8 says 6 1/3 plus 5 3/10. So we want to add these mixed numbers. And let me write these off to the side to get started. We have 6 1/3 plus 5 3/10. Okay, so there's a few ways you can go about doing this. You can pull the whole numbers aside and do 6 plus 5, which will be 11. And then you can work on the fractions separately, notably 1/3 plus 3/10. Or you can take these mixed numbers and convert them to improper fractions, add improper fractions, and then convert them back to mixed numbers. I think this way is a little bit easier because we already did 6 plus 5. We're halfway done right now. We just got to figure out what 1/3 plus 3/10 is. So let's go ahead and think about how we're going to do that. Again, in order to add these fractions, they have to have the same denominators. As we can see, we have denominators of 3 and 10. So one strategy I can take to solve this one is to rewrite the denominators as a common factor of both 3 and 10, which would be 30. Okay. In order to make this 330, I would multiply it by 10. Again, 3 times 10 is 30, and I'd have to also do that to its numerator, and 1 times 10 is 10. In order to make this 1030, I'd have to multiply by 3. Again, 10 times 3 is 30. To make this, and I also have to multiply its numerator now by that. 3 times 3 is 9. Now that the numerators are the same, we can go ahead and add these together. We have 10 plus 9, which is 19 over 30. Let's go ahead and combine our whole number with our fraction, and we can see that this is 11 and 19 over 30, which is answer choice C. A lot of approaches to working with fractions and mixed numbers. In this case, I broke the mixed numbers apart and I worked with the whole numbers separately of the fractions. Okay, so that's one strategy you can take to solve problems like these. All right, so for number 9, we have 12 times parentheses 82 minus 3 minus parentheses 2 times 81. So in order to get this one right, you have to be mindful of the order of operations. More often than not, people remember the order of operations by using an acronym PEMDAS. And what this stands for is the order in which you work out expressions like this one. You work out what's in parentheses first, that's the P. You work out exponents next, if there are any. Then you perform multiplication and division as they appear in your expression from left to right. And then finally, you work out addition and subtraction as they appear in your expression from left to right. That is to say, multiplication and division have equal precedence, and addition and subtraction have equal precedence as well. So in this case, if we, let's start by writing our expression off to the side. We have 12 times 82 minus 3 minus 2 times 81. So in this case, we do have parentheses, and we want to work out, according to the order of operations, what's in parentheses first. So let's go ahead and do that. We have 12. 82 minus 3 is going to be 79 minus 2 times 81. We can do that off to the side if we need to. 1 times 2 is 2. 8 times 2 is 16. So this is minus 162. All right, so we worked out parentheses. As we look through our expression, we don't see any exponents. Now we're working on multiplication and division as they appear from left to right. And as you can see, we have 12 times 79 minus 162. So multiplication and division come before addition and subtraction. So we're going to do this 79 times 12 next. So let's work this out. 9 times 2 is 18, so we're going to carry a 1. 7 times 2 is 14, plus 1 is 15. Before we start multiplication with the 0, we're going to bring down a 0 placeholder. 1 times 9 is 9. 7 times 1 is 7. Let's add these together. 8 plus 0 is 8. 9 plus 5 is 14. Carry a 1. 7 plus 1 is 8, plus 1 is 9. So this becomes 948 minus 162. We have no multiplication or division left. The only thing we have left is subtraction, so we'll go ahead and do that now. We have 948 minus 162. 8 minus 2 is going to be 6. 4 minus 6 we can't do, so we have to borrow. This becomes 8. This becomes 14. 14 minus 6 is 8. 8 minus 1 is 7. So we can see that this reduces to 786, which is answer choice B. So again, order of operations is something you will see on the ASVAB. Make sure you understand it. Make sure you do additional practice problems because they're not always going to be as simple as this one. All right, so let's move on to number 10. All right, so number 10 says if x equals 6, y equals negative 2, and z equals 3, what is the value of the following expression? We have x times z plus z times y over z squared. To start, I'm going to copy this expression off to the left. So again, we have x times z plus z times y all over z squared. That looks like a 2, so let me fix it. Z squared. And according to the problem, we know x equals 6, y equals negative 2, and z equals 3. So let's just plug those values into this expression. Again, let's get started with this numerator. We have x, which is 6, times z, which is 3, plus z, which is 3, times y, which is negative 2, all over z, which is 3 squared. Let's keep reducing this. 6 times 3 is going to be 18, plus 3 times 2 are negative 2. Again, a positive times a negative is going to be negative 6 over 3 squared, which is going to be 9. 18 minus 6 is going to be 12, so this is 12 over 9. Unfortunately, we don't see that as one of our answer choices, so we're going to have to convert this to a mixed number, more than likely. And the way you do that is like this. You treat this like long division. Notably, you read it as 12 divided by 9. Now we're asking ourselves, how many times does 9 go into 12? Well, that's 1 time. 1 times 9 is 9. 12 minus 9 is going to be 9, 10, 11, 12, 3. Okay, so that's all you have to do for converting a fraction to long division. Again, this is going to be our whole number, so it's going to be 1. This remainder is going to be our numerator, so it's going to be 3. And then this is going to be our denominator, which is 9. 3 over 9, of course, can be reduced by a common factor of 3. So 3 divided by 3 is 1. 9 divided by 3 is 3. So the answer to this one is 1 1/3, which is D. Okay, so that's that one. All right, number 11 says, what is another way to write 2.25 times 10 squared? Okay, so let's go ahead and work on this one. Again, we have 2.25 times 10 squared. 10 squared is the same as 10 times 10. If you can't do it mentally, you may want to work it out so you don't make any mistakes. 0 times 0 is 0. 1 times 0 is 0. Let's go ahead and start multiplication with this 1, which means we have to bring down a 0 placeholder. 1 times 0 is 0. 1 times 1 is 100. 0 plus 100 is 100. So this is 2.25 times 100. Okay? Instead of working this out by hand, all you do is have to realize that when you multiply a number by a power of 10, you just take its decimal and you shift it to the right according to how many zeros there are in the power of 10. In 100, there are 2 zeros, so we're going to take the decimal and 2.25 and shift it 2 times to the right to make it 225, which we can see as answer choice A. Okay? Now, if you didn't realize that you could do that, you would have to work out 2.25 times 100, which is very tedious and time consuming. So again, you have to get comfortable making these shortcuts like this to be successful on the ASVAB. All right, number 12 says, find the equation of a line that passes through the points 0, -1, and 3, 5. So to write the equation of any line, you're going to need a slope, which is going to be represented by m. And you're also going to need either the point slope equation or slope intercept equation. In this case, when you're just given 2 points on a line, you're going to use the point slope equation, which is this: y minus y1 equals m times x minus x1. M is your slope, as I just mentioned, whereas y1 and x1 are values of an ordered pair. That said, before you can use this equation to write the equation of the line, you have to figure out what m is. Again, m is slope, and it's given by this formula: y2 minus y1 over x2 minus x1. And you might be saying to yourself, where do I get x1, y1, x2, y2? Again, those are values of your ordered pairs. So we can let this be x1, y1, and this would be x2, y2. So let's start by finding the slope, which will then plug into the point slope equation to write this equation. Again, y2 is right here. It's 5 minus y1, which is -1, over x2, which is 3, minus x1, which is 0. Let's work this out. 5 minus -1 is the same as 5 plus 1. So this becomes 6 over 3. 6 over 3 is just 2. So now that we know what m is, we can start plugging some values into this point slope equation, which will enable us to write our equation of the line pretty quickly. Again, we're going to leave y as is. Y to the 1 is right here. We let that be -1, so let's just plug it in here. M we found to be 2, so let's put 2 in place of m times x minus x1 is right here at 0. All right, so let's keep working this out. We have y minus -1, which is the same as y plus 1. And let's take this 2 and distribute it here and here. So 2 times x is 2x. 2 times 0 is just 0. All right, so traditionally, equations of lines are written as y equals something. So we want to get y by itself. So we're going to take 1 and subtract it from both sides. This crosses out here, leaving you with y equals 2x minus 1. As you can see, that is answer choice A. All right, so that's that one. All right, number 13 says factor 4x to the third plus 2x squared minus 2x minus 1. So whenever you have to factor equations in which there are, or expressions in which there are 4 terms, you should automatically start thinking about factoring by grouping. Let's copy this down to the side. We have 4x cubed plus 2x squared minus 2x minus 1. The way factoring by grouping works is like this. You try to break down your equation into 2 equal parts, and you factor those 2 equal parts separately. So right now, I'm just looking at this first pair of terms, notably 4x cubed plus 2x squared. I'm trying to see what I can factor out from them. I know I can factor out a 2x squared, which will leave me with 2x, and then plus 1 here. Now my goal, once I start factoring the second half of this equation, is to factor it such that I get the same thing in parentheses here. And that's not going to be as difficult to do as you think. If I factor out a -1, that will leave me with 2x plus 1, which is identical to what we have here. Now we just combine these two, notably 2x squared and -1 into one term, so 2x squared minus 1. And then we just bring down one of the repeated terms, so that's going to be 2x plus 1. And just like that, we factored this one by grouping. It's 2x squared minus 1 and 2x plus 1, which we can see is B. Okay? And I do have a video on factoring by grouping. I think I have 4 or 5 videos on my channel in regard to factoring. Again, you do have to be fairly good at factoring for the ASVAB. So be prepared to understand how to factor by grouping, as well as how to factor some basic quadratic equations. All right, number 14 says a circular flower bed is surrounded by a 1 meter wide path. The diameter of the flower bed is 6 meters. Find the area of the path. So for this problem, we have a flower bed that's circular, so it looks like this. That's surrounded by a 1 meter wide path, which kind of looks like this. According to the problem, we know that the diameter of the flower bed itself is 6 meters, and diameter is the distance from one edge of the circle to the other edge of the circle and through its center point. So we know that's the diameter there for the flower bed, and we know according to the problem that's 6 meters. Similarly, we know the path is 1 meter wide. So if I continue this line from here to here, I know that distance is 1 meter. If I continue this line from here to here, I know that distance likewise is 1 meter. Okay, so in order to find the area of just this 1 meter wide path, what we're going to have to do is find the area of this big circle, and we're going to subtract it by the area of the flower bed, and that's going to give us the area of just this 1 meter wide path. And that looks like this. Area of, let's call it BC for big circle, minus the area of the FB for flower bed. That's what we need to do to find the area of the path. We'll call that A of P for path. Okay, so let's think about how we're going to find the area of these things. Again, they're circles, so we know we're going to use the formula area equals pi r squared, where pi stands for, we're going to use 3.14 pi, and the radius is always half the distance of the diameter. So radius is always diameter divided by 2, okay? So let's separate these two circles and see what we have going on. We have this big circle, and we know its diameter is pretty easy to figure out. Again, the diameter of this flower bed is 6, plus 1 is 7, plus 1 is 8. So the diameter of this big flower, this big circle is going to be 8 meters. So let's find the area of this big circle. So that's going to be area of big circle equals pi. Radius is always diameter over 2. The diameter here is 8, so 8 divided by 2 is going to be 4. So this is going to be pi times 4 squared. Let's go ahead and work that out. Area of the big circle is equal to 4 squared times pi, which is going to be 16 pi. Let's go ahead and work this out by replacing pi with 3.14. So this becomes 16 times 3.14. And I'm going to work that off to the side so I don't make any mistakes here. That's going to be 3.14 times 16. Again, we're doing multiplication involving a decimal and a whole number, so you want to shift this decimal in 3.14 2 times to the right such that 3.14 becomes 314. We're going to multiply that by 16, and once we finish doing that, we'll go ahead and shift those two decimals back into the left. 4 times 6 is 24, so bring down a 4, carry a 2. 1 times 6 is 6, plus 2 is 8. 3 times 6 is 18. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. Let's add these together. 4 plus 0 is 4. 8 plus 4 is 12. Carry a 1. 8 plus 1 is 9, plus 1 is 10. Carry a 1. 3 plus 1 is 4, plus 1 is 5. Bring our two decimals back into the left. 1, 2. So we can see that the area of this big circle is 50, 24. Okay? Now we got to find the area of just the flower bed, and we know that. We'll go ahead and do that. Let's get rid of this. This is from a previous problem. The area of the flower bed has a diameter of 6 meters. So let's go ahead and do, where do I want to do that at? Let's do that down here. Area of the flower bed, again, it's going to be pi r squared. We know the diameter of the flower bed according to the problem is 6. So its radius is going to be 6 over 2, which is going to be 3. So this is area of flower bed equals pi. 6 over 2 is 3 squared. So this becomes area of the flower bed equals 3 squared is 9 pi. Let's go ahead and work this out by replacing pi with 3.14. So this becomes 9 times 3.14. Again, we're doing multiplication involving a decimal and a whole number. So we're going to want to shift the decimal place 2 times in 3.14 such that it becomes 314 times 9, albeit with 2 decimals to shift back into the left when we're done. 9 times 4 is 36, carry a 3. 9 times 1 is 9, 10, 11, 12, carry a 1. 9 times 3 is 27, 28. Shift our 2 decimals back in. So the area of this flower bed is 28, 26. And again, let's just plug things into our formula here. Area of just the path is going to be the area of the big circle, which we found to be 50, 24, minus the area of just the flower bed, which is going to be 28, 26. And if you can't do that in your head, you can work it off to the side. We have 50, 24 minus 28, 26. 4 minus 6 we can't do, so we have to borrow. This becomes 1, this becomes 14. 14 minus 6 is 8. 1 minus 2 we can't do, so we have to borrow. We can't borrow from this 0, so we're going to have to borrow from this 5. It's going to become 4. This is going to become 10. Borrow one more time, so that becomes 9, and this becomes 11. 11 minus 2 is going to be 9. Drop down your decimal in place. 9 minus 8 is 1, and 4 minus 2 is 2. So this is going to be, area of just the path is going to be 2198, which is answer choice A. And of course, that's going to be meters squared. Okay, so that's that one. Pretty challenging problem. You had to find the area twice, which is good practice for the ASVAB. So expect to know how to find the area of circles as well as the circumference of circles. You will see those questions on the ASVAB, almost guaranteed. All right, number 15 says, solve the following system of equations. We have 2x minus y equals negative 5 and y equals negative 1 plus x. So to start, I'm simply going to copy this down to the left. So we have 2x minus y equals negative 5. Then we have y equals negative 1 plus x. As you can see, these equations are not written the same way. We have x and y on this side, whereas we only have y on this side of the equal sign. So the very first thing I'm going to do is rewrite this bottom equation such that it's of the same form of this top equation. And to do that, I'm going to subtract x from both sides. This will cross out here, and this will become negative x plus y equals negative 1. And let's just copy down this top equation over here. We have 2x minus y equals negative 5. All right, now that the equations are written in the same way, we have to think about how we're going to solve this system of equations. And there's two ways you can solve a system of equations. You can either use the substitution method or the elimination method. If you really wanted to, you can use linear algebra, but that's usually beyond the scope of what people are taught in high school. So if we think about using the elimination method, we want to multiply one or both of the equations by a constant such that one of the variables is eliminated. In this case, we don't have to multiply either of these equations by anything because we have negative y here and positive y here. I know that if I add these two equations together, this y variable is going to drop away. It's going to drop out. Negative y plus y is nothing. So 2x minus x is just x. As I mentioned, negative y plus y is nothing. And then negative 5 plus negative 1 is negative 6. So as we can see, x is negative 6. Now that we've solved for x, we take our x value and we plug it into one of the two original equations, and then we solve for y. So I'm going to plug it into this second equation. Again, this second equation was y equals negative 1 plus x. We now know x is negative 6, so in place of x, let's put negative 6. y equals negative 1 plus 6. Again, we know x is negative 6, so this is really just minus 6. So y equals negative 1 minus 6 is negative 7. Okay, so we know the solution to this system of equations is negative 6, negative 7. If we write that as an ordered pair, it's going to be negative 6, negative 7, which is going to be C. Okay, so that's that one. Again, I do have 1 or 2 videos on how to deal with systems of equations on my channel. So check out that video if you need some help with those. All right, so let's look at number 16 now. As we can see, it says 2x to the 4th, y to the negative 4th, over 8x to the 7th, y to the negative 3. And we want to simplify this. So to start, I'm going to copy this down to the left. We have 2x to the 4th, y to the negative 4th, over 8x to the 7th, y to the 3rd. And we're going to have to use the laws of exponents to simplify this expression. More specifically, since we have this division bar here, again, fractions can be treated as division, we're going to have to make use of the quotient rule. And a little later, we're going to have to make use of the product rule. The quotient rule says this: if you have a to the m over a to the n, that's the same as a to the m minus n, okay? And the product rule says if you have a to the m times a to the n, that's the same as a to the m plus n. All right, so we're going to use these two rules a little bit later, but let's start by dealing with some simple things first. Let's disregard these x's and y's momentarily, and let's just work on this 2/8. Again, we know this is all going to be in the same fraction, but that said, let's pull out this 2/8 to the side. If we were just trying to simplify this fraction, we could divide the numerator, that is 2, and the denominator, that is 8, by a common factor of 2. 2 divided by 2 would be 1, and 8 divided by 2 would be 4. So we've dealt with this 2/8. It reduces to 1/4. Okay? Right here, x to the 4th over x to the 7th, we have an instance of the quotient rule. Again, we in place of m, you could put 4, and in place of n, you could put 7. So this looks like this separately. We have x to the 4th over x to the 7th. And according to the quotient rule, this is going to become x to the 4 minus 7, which is the same as 4 minus 7 is negative 3. Okay, so this becomes x to the negative 3. We're going to deal with that in just a minute. Don't get alarmed that I'm leaving a negative there. So we dealt with these for the most part, but we're going to come back to them. When you have a negative exponent, it cannot stay in the numerator and it cannot stay negative. So what you have to do is realize that when this y to the negative 4th crosses this division line, it becomes positive. So this y to the negative 4th really looks like this. Y to the 4th should be in the denominator, okay? And now we can use the product rule to simplify y to the 3rd times y to the 4th. Again, that's what we have going on right here. So we have y to the 3rd times y to the, my pen's not working, come on. So we have y to the 3rd times y to the 4th. According to the product rule, we simply add the exponents, so this becomes y to the 3 plus 4, which is y to the 7th. And we know that these are in the denominator, so we're going to leave them as is. So this is y to the 7th. Let me fix that. My pen is starting to act up a little bit. Y to the 7th. Okay, so we're almost done. We've used the quotient rule as well as the product rule to deal with these things. That said, we can't leave this negative exponent here. Instead, we have to bring it across this division bracket. such that it becomes positive. So this is going to be 1 over 4. By bringing x to the negative third to the denominator, its exponent becomes positive 3. And then we have y to the 7th. Now that we have no negatives and we've simplified everything else using the product and quotient rule, we are finished. And we can see that this is answer choice D. Okay, so that's that one. All right, so that's it for this video. I hope you found it helpful. As I mentioned at the beginning of this video, you should really watch at least 10 of these practice videos in order to get a feel for what's going to show up on the mathematics knowledge subtest. In all honesty, it's very difficult for me to pick problems that are going to very closely mirror what you'll see on your version of the ASVAB in just one practice test. So again, try to watch at least 10 of them. As always, you're more than welcome to leave feedback in the comment section below. And if you like the content I'm creating, please consider subscribing to my channel. That's always very helpful. But on that note, I'm going to go ahead and cut you loose. Konnichiwa.